Welcome back. Let's continue the dungeon crawler. Today I want to focus on improving the code, especially the world update system. So this is a TechDev file. I actually need to add an additional entry that says that enemies are not bound to a floor. Okay, I want to start with the world update system. So what I'll do is I'll make a section called doing, and let's see what we need to do here. So our world update system currently does a couple of things. It updates the world itself. So in terms of naming, that's actually quite okay. It updates the player's position in the world, in the sense that it puts the camera in the right position, and it renders the current floor if the floor changed. And so it's really taking up three different aspects. And then it's also doing this render enemy, which I guess it was just a hack to get something on the screen. So I think we should start taking this out a bit. And perhaps the best thing we can do for now is to assume that most of the stuff here is related to drawing the map. So what if we renamed this thing into map update system, and we duplicate this one. There should be a function somewhere, and we will create a new world update system, and we'll take out everything that's related to the map. So this, of course, duplicates the entire file. So we'll create a world update system that indeed can take a world. It should have a camera actor, but it doesn't need a floor, it doesn't need a map, and it doesn't need, I think, a model cache. So we can start taking up stuff out. So we can find the world component, and the world. We can find the camera anchor, and we can still do the world update and the camera anchor updating the position and the direction. And I think we don't need all this additional stuff. So this becomes a nice and clean, small component. That also means that in our map update system, did we? Oh, I renamed the wrong file. I guess these things happen. So this is the map update system. So I'll rename this file for a bit, and then I'll rename this to the map update system. So it did update the type, but it didn't update the file name. And now I can call this the world update system, the one that only updates the world. And then in the map update system, I can take out the camera anchor, because we don't need that one here. We can take out updating of the world and the camera anchor, and the rest, I guess, can stay the same for now. So fortunately, we don't have tests to drive this, so we'll just have to do a build and run to see what the effect of this is. And while pressing this, I remember that I forgot to actually register our new system. So we have our map update system. We should also have a world update system that we need to register. Let's see if this helps. So we now have more or less the same thing we had before. So we can still move around and even win the game. Now we have a world update system and a map update system. There is no reason why we couldn't also create one that updates the enemies in sort of an enemy update system. So we'll create a new file. This will be an enemy update system, and it will be very similar to the map update system. So I'm going to just copy paste some stuff and see how much we can reuse. So again, this will require a world. I don't think we need a rendered floor. I don't know if we need an anchor for the entities, but I think it could be a good idea. I don't think we need a model cache for now. And I guess we need to import RealityKit. So we have a world, then we have an update. We could just say render enemies. And this is something we will do all the time. If we don't have an enemy anchor, or if we have an enemy anchor, what can we do? Wait a sec. We can just create one, I think, right here. And we can say add child or add anchor, enemy anchor. So we have now access to some place where you can put the enemies, and we can get rid of all this stuff. We still have this render enemy that takes enemy anchor. What do I need to get these colors in? I guess Swift UI is enough. We don't need this load entity. This one will be called render enemies. We also don't need these old functions. So there is our enemy. However, we still have him also here, so we should get rid of him from this one. Then we can get rid of the render enemy function. We can run, and now we don't have the enemy on screen anymore because we didn't. We should also register our enemy update system. Okay, now we also have our enemy right here. And it looks weird because we're rendering many different enemies every frame. So this is not how this should work. For now, let's see. What we need is a way of associating. Like, the big difference between the map and the enemies is that the enemies are more dynamic and more mobile. So the map is more or less something that stays the same as long as you don't change your floors. However, enemies can move around, rotate, and stuff like that. So what we could do is remove all the enemies at the start of every frame and then redrawing them in the correct positions and orientations and with the right animation frames and stuff like that. But it's kind of wasteful. So what I'm looking for is something we did earlier, is that we associate the sprite with an actual enemy. So we could create a private variable called enemy sprite map that takes an enemy and maps to a RealityKit anchor. And that means that enemies should conform to hashable. I hope we can, well, it's okay if we added conformance here. This doesn't feel very well doing it like this. So what I'm going to do is I'm going to create an extension here called enemy. And I'll probably get an error that I can't, I need to add some stubs to make them conform to equatable. This isn't really what I need. So what I should do probably is use an object identifier. That's basically the address of the entity in memory. Basically, that's what uniquely identifies a specific enemy instance, and we'll map that to RealityKit anchor entity. So what we now can do is we could say we will render an enemy. What we could say is for enemy in world.enemies. Not sure. Perhaps that one is not. That's private. Okay. We'll add. We'll make sure that we can get. I'll just return our enemies for now. And now this should no longer be this is not private, so we can say enemies on current floor. And now we can pass in an enemy. And what we could do is we could say that if let sprite is enemy sprite map with the object identifier of our enemy, we don't do anything yet. So here we can do updates and stuff here. Otherwise, we do all this stuff. Basically, we create a new one. And the big difference is that at the end, we say our enemy sprite map for this object identifier will be our sprite anchor. And this anchor will be our enemy anchor. And now we should be back to the existing behavior. However, we indeed do, but now we can start working on making sure that it rotates around to keep facing us. So we're going to billboard it as a start, and when we get a bit further, we can make sure that the correct direction sprite is shown. But first, we'll make sure that it billboards. This requires a bit of extra work. So we have our sprite. What we can do is we can use our sprite transform rotation, and we can set it to an angle of world the party heading to float quaternion, the angle, and our axis will be up, I don't think we have a short. Do we have a shorthand for that? I guess so. Oh, we don't. And this will be something like this. And let's see if this now starts being more visible also from other sides. So looked at it now, keeps facing us. It looks like it's rotating. That's actually not what we want. Eventually, we want to change the sprite based on where the skeleton is looking at. I think it's looking in the direction of where, in this direction, in the internal model. So what we want is we want to have a sprite now shown that it's showing it from the side. However, this at least makes sure that you always see a sprite dead on, basically giving the impression of depth. So we need to start switching out sprites. And now let's do something about lighting, because as you notice, the further away, the more it looks like the skeleton is glowing, because everything around it gets darker, and except for the skeleton. So let's use the function we had here for that as well. To do that, we need to more or less recreate the sprite material each and every time, including the model component. So that's a bit of a hassle, I would say. So maybe we should create a function that just gets us the correct model components. We can create a function called make a model component. This returns a model component. And we simply put in all this stuff. Including this one. And then we can the model component. Well, the make model component function here. And we can just return this one. And this should be more or less the same as what we had before. Okay. Now we have this function. We're going to use it up here as well. So we'll take a sprite, and then we take first child, because that is the actual sprite. The components, we can set the component to a new version by calling make model component. And let's see if this has the intended effect. So we now have a flickering sprite, which makes some form of sense. So let's do an actual light calculation by taking the inverse of the distance between our party position and our enemy's position. And then the magnitude, meaning we actually need to pass in the enemy. Okay, that's build and run. Okay, it's now a bit darker. We can come closer, it becomes lighter. We go even further away. It's even darker, so you can almost don't see it. And the closer you get, the lighter it becomes. So in a sense, this is more or less what we would expect to happen. And it's more or less blends in now with its surroundings. So that's that I think looks pretty well. I think this should be enough for now. Okay, let's look into our tech debt. So this one has been solved. I think next time we can start looking at creating a better initializer to create worlds, because that's something we'll probably do a lot, and making that a bit more elegant will probably give a lot of mileage going forward. So thanks for watching and have a great day.